Hello everyone, welcome back to Labtube. In this video, I'm going to do question 12 from the section 16.3, which asks to do this two-part question. First, it says that find a function f such that the vector field, this, is equal to gradient of that function. So basically what it means is that f is conservative and find its potential. That's other way of stating part A. And then it says part B, use the part A to evaluate line integral. And what is that? It is nothing but, so this is 1, 2, for conservative vector fields, meaning that for all vector fields, which is given by gradient of some function. So you can find the potential for that. If you have line integral along a curve going from a point to another point, the line integral is given by you just plug in endpoint in your potential. That gives you a number minus plug in the initial point in your potential function. Subtract them. It will give you the value of the line integral. This is fundamental theorem for line integrals. So then we have to do part A. So what is part A? It says find a function whose gradient is equal to that. Gradient of function is a function with two variables, is fx, fy. Yeah. And this question says that find f such that this is equal to this vector field. So 3 plus 2x y squared and 2x squared y. I have two vector fields. They are supposed to be equal to each other. What does that mean? It means that fx, partial derivative of x with respect to f with respect to x is equal to 3 plus 2x y squared, and partial derivative of y with respect to f with respect to y, f with respect to y is equal to 2x squared y. Okay, how can I find such f? Okay, if there exists such f, which we know exists, if I integrate with respect to x, I'm going to get f. So it's going to be fx dx. So integrate this with respect to x, meaning that I'm going to get 3x dot, and this guy is going to be x squared y squared. But if you remember from antiderivative, the way we find antiderivative, I can have any constant here, yes, any constant c. But if you notice, I just integrated with respect to x. That means that constant can be anything in terms of y. So basically, I don't have constant. It might be the case that we have, instead of constant, we have a function completely in terms of y. Okay, so that's what we get from this. But if I have f given by such formula, what would be fy? Fy means you find partial derivative of this with respect to y. So partial derivative of this with respect to y is 0, plus partial derivative of that is this, plus partial derivative of function with respect to y. This is just derivative of that function. Okay, that's good, but this is where I started. Now, I go back to my original condition and I see that I already have a candidate for fy. So that means my fy, these two should be equal. But if we set them equal to each other, 2x squared y is equal to 2x squared y plus c prime y, that means this cancels with that. C prime y is equal to 0. That means cy is equal to constant. So in this case, it happened that we have this equal to constant. So my potential is equal to f of x, y is equal to, I have it here, 3x plus x squared, y squared, plus any constant. I can put that constant c, but at this moment it doesn't matter. Okay, so that's part A. Now I'm done with part A. Part B, use that to evaluate the line integral of f dr. By fundamental theorem for line integrals, I know that this is the value of the function, potential function, at the end point. That is the end point. So I just plug in 1 over 1 over 4 minus value of the function in the initial point, which is this. So f of 1, 1. Yes, just plug in those values and you get, so I have 3 plus 1 over 16 minus, as I said, I can put any c here. They will cancel each other. So I choose to put 0 there. For 1, I get 3 plus 1. And if you do these two cancels, I get 1 over 16 minus 1, which is negative 1 over 15, 16. Okay, very quick wrap up. Part A says find a function whose gradient is equal to that vector field. That means find a potential for that function, for vector field. That means a function whose gradient is equal to that. So I set them equal to each other. I started from this. That means if I integrate with respect to x, I'm going to have this kind of function. If I find derivative of that with respect to y, I go down, I got this. But if y I know already it is equal to these things, I set them equal to each other. I find an equation for c prime, which gives us that c y is just constant. So basically that way I find the potential. And then when you find the potential, line integral of a conservative vector field is easy. What you do is just plug in the endpoint in your potential minus initial point in potential. Subtract it, you get the value. And that's how you find integral of a vector field if you know that vector field is conservative. Have a great day. Thank you for watching this video.